it's a grim, dark, dystopia, I think, with that we're looking at, and hopefully we don't go there.
So, Brian, you're currently working at, should we say, a big tech company, Salesforce. I think they count as big tech, and you're building a
So,
startup. How's that going?
yeah, it's an interesting question. I've enjoyed it, and not to not to open with free advertisement for you or anything, but I do still attribute part of that to, finding you and following you on LinkedIn and just deciding like, man, I've been doing a lot of the same thing for a really long time at my day job. It's like I've been writing React code since the dawn of time. And, I just want to do something different. And I had this idea for my project, Meet Near Me. And it was like, what if you could take and plug in 10 different URLs for places that list events, because nobody really has a comprehensive index of that. So it started off as a tool. It was a mentoring group that I converted into a group building a real project, and then turned into a company. But the day job part is definitely, um, it's challenging. Like, I just had my team grow from 10 to 40, like in the last 3 weeks, I guess. And so, for example, I've had less time for my side project, obviously, so it's tough to do both. At the same time, I work, yeah, I love the controversy around people who get mad at people for waking up early and being hustlers or whatever. That's what works for me. I get up at 4 a.m. and that's how I get it done. Basically having two jobs, So, but yeah, it's interesting, dynamic for sure. Always having to balance between the two and managing two different teams, and there's all kinds of different stuff involved.
I'm curious. I've always considered myself a morning person, but 4 a.m. is a bit too early for me. 6 a.m. maybe, but okay, cool. Well, that's really interesting to hear that. I was partly inspired that. I love the fact that the mentoring group has transitioned into this building a company. So you're really helping people learn by doing, which is something I'm always keen to push. So how did that mentoring group evolve into the people building a product, and how does it work for the people that are in that group?
Yeah, it's a great question. All respect to the folks who are on my team. I greatly appreciate all of them. But the interesting part is really unusual is the fact that, I mean, everyone who works for me is fairly new, ranging from my star pupil, who I won't name just for privacy, but he started 6 years ago, and I've mentored him the whole time. I've led teams for a long time, but I've closely individually mentored people that are not on my team at work, maybe 4 times, and this is the first one that's really taken off. You know what I mean? And so he's like very, very close to getting his first official tech job. Technically, I'm paying him and he works for me. And so really that's also definitely a tech job that he's already got, working for me. But anyway, so he was in the mentoring group. The other person currently on my team was not in the mentoring group. I met him later after the fact. But when I started that mentoring group, and I was giving a lot of resume critique and helping people to sort of refine their online brand and all of that, their public presentation of themselves. And at some point I just said, like, you know what, the problem is that these people, I'm not in their projects, like seeing what they're doing wrong. You know what I mean? Sure, I can look at their GitHub portfolio, but I don't really know what's holding them back. And so I decided to transition it like that, as you said, into building that project, or that sort of real tool. And it's been a great time. You know, it's a wild ride because I have not had the benefit that some people have, like, say you and I founded a company as two technical people, but there's only so much room for that. There's only so much room for so many people. It's like, first I got to get it to pay one person. That's a challenge in itself before I think about, let's get two very experienced people like me and you or something on it. That would be kind of a venture capital backed from day one sort of thing, which is different than what I'm trying to do, bootstrapping this. So, but anyway, yeah. So my whole team is new, and it makes you painfully aware of the amplification of your own mistakes, right? So like, for example, something you and I have sometimes chatted about, like TDD, and it's controversial because I always say that in front end land, the problem is the spec is never real. It's always a lie, right? It's not actually done. And it's hard to build to spec and to like write those tests and then, go from there, because it's not true. If they change it, the design team changes it, the product team changes it over and over and over again. And so, anyway, I very much believe in testing, but it comes to mind because it's like I probably, because I'm more front end leaning and less back end leaning, I've done less of test driven development kind of mindset. And because of that, I see times when it's like, man, I just really wish I had more tests on this, more coverage, and not just to make the metrics look good from a percentage perspective, because you can just assert nothing and get 100% coverage, but from like a, hey, are all the happy paths covered? It's like I'm always fighting to get there, but it's hard when you have two jobs and two teams. It's like I'm managing people, I'm writing my own code, I'm trying to test my own code, I'm testing my code at work, I'm testing my code at my side project. So it's hard to keep up with, So that the junior aspect of the team is
So,
definitely a challenge. Yeah, sorry, go ahead.
so I don't know. I hate to shatter the illusion or any kind of dream that TDD on the back end or in data engineering or in systems programming is any better. Honestly, I'm a big fan of TDD, but I have never worked in any area of the stack on any system, whatever it is, where the requirements have been static and where the requirements stay steady and where somebody doesn't change them almost as fast as they can, either because they haven't thought them through properly or because the world around us changes. Businesses evolve, the world evolves. I think whether you do TDD or not, there's always that constant challenge that requirements will change. And that even though we've known for decades that getting requirements right is so important, it's stuff that people don't like doing. So we tend not to do it and not put enough effort into it, whatever process your organization is and however big it is. So
Yeah,
I think it's a challenge
it's
with every way of working.
it's true too. And another way of thinking about that, is that just my take is uh, some of it has to do with how big is the mind castle that you have to construct. There are human limitations here. You know what I mean? That I think are at play too. Where that's where Agile comes in, right? The whole Agile movement is about the idea that hey, you can't get everything right out of the gate because nobody can imagine a future 12 months from now, 1 million lines of code later with 50 engineers or whatever it is. And so from that perspective, I think like there's a great influencer software engineer, the Primogen, who was an employee at Netflix, and he was chatting with people. He's actually chatting with Carson Gross, the creator of HTMX, and he had him on as a guest, and they were talking. Carson had written a paper. It was I think he called it like coding dirty or something. It was like the antithesis of clean code, because clean code is like, oh, I forget the number, shouldn't be more than 20 lines per function or something like that. And so there was this really great point that came up there, which was, hey, if your functions have only 20 lines at most, first off, it's hard to actually tell which ones are important because there's so many layers that you don't actually know how long the call chain really is. That's one problem. Secondly, and this is me especially, I really resonated with this. It's like I've got about 4 levels of nesting before I forget where I started, right? And so, I tie all this into the question of big requirements, because it's like when you have this big mind castle that you're trying to construct, and you get into like breaking it all down into these tiny little pieces that hopefully are manageable. Eventually, you can't remember the top where you came from, or the sort of start of the call chain. And so, I think like in that way, I'm sympathetic to the whole agile thing, and agile is kind of like pushing back and forth between like get all the requirements right up front versus, like let's wait until we actually understand the problem. I always advocate on my teams. I'm like, before you try to write the requirements, have you tried writing a steel thread or a proof of concept or writing some code about this? Because like if not, I don't think we're ready to talk about this, So that's my bias anyway. I'm curious your take.
So there's a couple of things there. I'll start with the 20-line functions. I have almost the opposite view of that. I take the view that if a function is longer than 20 lines, bigger than it will fit on one page of A4 or one screen of code without having to scroll, then I can't see it all in one go. You can't get it all in your head. You can't reason about all the different paths through that function. And if a function does one thing and one thing only, and it's 20 lines or less, it can be very well understood, it can be very well tested, and it's very easy to reason about. In contrast, I've come across a couple of functions in the past that were over 800 lines long. They're impossible to reason about because there's so many levels of nesting, there's so many levels scrolling up and down to try and find where this if block or else block ties to and what the condition was. So I think very much 20 lines of code is it's not hard and fast. Sometimes 10 lines will be more than enough because of the complexity of what you're doing. Sometimes 22 lines might work, but roughly a page of A4, one screen of code, I think is the limit of what you can reasonably reason about. And I don't care about the chain of function calls because a function should tell me what it does, should be so obvious from the name and the parameters. And if it's well tested, I don't need to go into that function to see what it does. I can read it, see that, this function fetches X from database or something, and I don't need to care how it does it. So I can reason about the higher level one without going into the levels. So that's my angle on that point of view. And I also think that if your functions if you're 20 lines or less and they've got one or two parameters and a very clear single responsibility, they do one thing, they're also very simple to test. They will tend to be very functional, minimal side effects, and they're easy to test and then validate that they work. So I don't tend towards hard and fast rules, but most of my functions will be 20 lines or less.
I get the testing part. I think the part that gets me, and this is really fascinating because I'm really interested in this. It seems like it's actually just a cognitive difference in how the brain works, like between you and I, right? It's like for me, jumping to a different file or like where a function is declared somewhere else, that causes a loss of context for me, whereas scrolling doesn't. So like I have a different experience on that. But obviously we want things to be small, testable. You know what I mean? Like you want to prevent them from kind of exploding in complexity. But like for me, the naming of the function and it like its name should say what it does. Like it doesn't work for me because the name never really tells you exactly what it. Yeah, sure. When you're at 20 lines, you're more likely for it to tell me in very specific detail what it does. That's true, but I'm thinking about like I need to know the inner logic, and so when I can see it all together, it helps, But it's interesting, super interesting.
But again, if you're absolutely max at 20 lines, or 20-ish, and most of them are 5 to 10 lines, the inner logic almost doesn't matter because the name will tell you precisely what it does. You can go too far with this. I've seen things where every single function is 2 or 3 lines long. And then, as you say, you're looking everywhere trying to work out what the functions are. So there's a balance to be struck with all of it, that you can have too much abstraction and too little.
Yeah.
But that's, again, I think you have a different approach when you're doing it with TDD, and that you tend to be thinking of like, what's the next small chunk of feature I can do? Mm-hmm. And that leads you to building small functions with one responsibility. It's very clear what they do. They're very well tested. They tend not to have side effects because so you can look at the name and the parameters and it's immediately obvious what they do. But the joy of software is that there are different ways we can approach this. There's no right and wrong answer. Mm-hmm. And so, part of this has to flex in what your team is used to. The only thing I'd say is wrong is a function that's 1,000 lines of code. That's hard for anyone to follow because it's going to have a lot of nesting or a lot of something that... and the other joy I've come across with a function that had 72 parameters.
Yeah, I have a function that has like 20 because they're all query params, and it just reduces the query params into what the database call is, because they're all facets. But yeah, I agree. Like I don't like to
Yes,
have,
there's always exceptions like that.
yeah. No, but it's a good call out. And yeah, I think we are very different. Like I think I'm comfortable with like a couple hundred lines, and I find that I generally go to 200, and then I start to abstract and pull that out, right? Like pieces in the way that you're talking. It's like you build from the bottom up. I tend to build from the top down, right? And I'm like, okay, I'm at my 200, which is sort of typical for me, and now I'm going to start to like let me pull out 30 lines here. Let me, with some abstraction, right? But only after I feel like it tells the whole story, So, but anyway, we could go on forever. But that's why I said I think it's interesting because I think it's almost a cognitive difference in just like how my brain works versus yours or something like that.
So I'll pick out two things there. One, I start outside in. So I start from that top level function and I build a bit at a time. And I will start with that high level function. And when it gets to a point where it does something and there's something obvious that I could extract, then I will start refactoring it. So quite often I'll start with, maybe I'm doing a feature, it might start as one function. As it grows, maybe it gets to 10, maybe it gets 20, maybe it gets to 30 lines, I will pull out some other function of that. Or maybe as I'm building it, it's obvious that I need to, let's say, go and fetch some data from a database. I might decide that's a separate function right off because I know I'm going to want that. And I want to keep that a little bit of abstraction so I could fetch that data from wherever, and this function at the top level doesn't need to. So I start top down too, or outside in, depending on terminology.
Has Go influenced your line count at all? Because 5 lines just for the if error not equal nil, then condition. You know what I mean? Like there's not now you've only got three function calls or four that at most that you can fit in that 20 lines. You know.
Well, like I say, it's not hard and fast at 20. It's whatever fits on a page.
Yeah, sure.
I'm fairly certain that in my Go projects, like if I think about Redis and Memcached and the interpreters and compilers I've been building recently, there probably are 5 or 6 functions in there that are closer to 30 or 40 lines, where, as you say, they're doing quite a lot and they've got quite a lot of error checking. Go is a bit more verbose in that way.
Yeah.
But again, I don't mind that if it's an occasional thing, but still most of them will be in the smaller.
Yeah.
The other thing I was going to point out is you talk about the cognitive differences. And this is something I think that a lot of people get wrong about TDD, is, as far as I view it, TDD, test-driven development, and I'm talking about canon TDD as Kent Beck defines it here, is a way of building software. It's a way of building software that really works for me, fits with my mental model, fits with how I approach and break down a problem. And it actually fits with how I approach and break down writing an article, how I approach and break down, I don't know, cooking dinner, or, it fits with how I approach those things. So I like it for that reason. I have worked with enough software engineers now that I've seen people build very, very good, high quality software, sometimes better than I would build, by writing their code first and writing their tests afterwards. I've never seen anyone build high quality software without testing. Everybody that's built high quality software tests it. Even if it's manual and inefficient, they do testing. But you can build it, if it works for you cognitively, test-driven development, you can build it with test-last development, or some halfway house where you do some tests before, some tests during, some tests after.
Yeah.
To me, that's just a different cognitive load, and they're all equally valid. Now, TDD works really well for how I approach things, how I think of things, but I don't understand why more people can't take the passion away and think, well, it's an approach. If it works for me, great, do it. If it doesn't work for you, you don't need to argue and put somebody else down for doing it. Do test last, or do test in the middle, or do the kind of random hodgepodge that suits you. Because we 100%. All have different models. We have different mental models. We have different ways of approaching problem solving. So long as we get good quality software at the end, it doesn't matter. And I've worked on teams where I've done TDD because it's what I like, works for me. Somebody else on the team has done test last. Somebody else just likes their tests whenever they feel like it.
Yep.
it's still been
Yep.
good quality software, and we've been able to work
Yep.
completely
Yep.
both independently, and we've been able to pair. So it shouldn't be something that leads to people falling out. They're just, I don't know what the equivalent is in other areas, but there are lots of things where you can do stuff in different order. If you're cooking your dinner, I don't know, let's say you're going to have a curry, you can cook your rice before and keep it warm, or you can cook your rice after you've done everything else and leave your curry on to
Yeah.
stew.
Yep.
You're still going to get a nice
Yep.
meal at the end of it. It's still going to be the same food. They're both
Yep.
valid approaches.
Yeah, no, I agree. I think, and it's interesting because of those two things that we kind of just talked about, one being small functions, the other being like the order in which tests are written, right? I've just never had this idea until like right now talking about this with you, is wow, like the way that people's minds work might make a difference, not so much for when you write the tests. I think that one's a little less controversial, but like the size of functions and the level of interaction, like that one's a little bit tougher. Man, I'll never forget. I had a guy that was obviously into clean code on a team that I was on once, and it was routine for me to have to go into 7 levels of interaction. And I had somebody who was trying to just be an honest, helpful, like teammate, say like, maybe Brian, you should write them all down on a piece of paper every time you actually go through the maze of these 7 levels of indirect. Like it was more than 7, but minimum 7. You know what I mean? And I could never keep track of where I was when I was navigating that code, and that is actually more interesting to me because in that, like you and I on the same team might just there might not be an optimal way for us both to like process as efficiently, right? Like because you either have to have like big or small functions. You know what I mean? Like you can't. Sure, you and I might be able to meet in the middle. That would be an interesting thing to dive into the details where we actually look together at code and we say like what our preference is and can we like find some compromise. You know what I mean? But I'll never forget working on that code. It was like my clean code nightmare. I was like, oh my God, I can never find my way through this maze. Every time I start, it's like I never have been here before. You know, it was a kind of like a cognitive blindness or something like that. You know.
So that makes me think. I think there's another aspect to this then. One of the reasons I don't care about small functions and structuring my code that way is I think in most of my code, I've never gone more than 3 function calls deep. Nothing that I'm working on is complex enough to have more than that. Because I'm doing it with test-driven development, I'm very rarely actually running the code. I'm running the tests I'm working on. So I'm building a test for a feature or module that's very self-contained and closed. So most of what I'm doing does the top level function that I'm testing, and it never normally goes more than 2 or 3, maybe
Sounds
as case
like
4 levels
you
deep.
haven't written a lot of React code.
I do not do front-end development. I think I've probably written less than 5,000 lines of React code.
Yep. I've been writing all React code. And a lot of this is based on that. There was like an object that has as a key an ID and as a value a component. And then you multiply that to infinity, right? You know what I mean? It's like component nesting in React is where this comes in like a lot of my experience. And writing Go, like I said, which I've been doing more of, much less of this, which has been a breath of fresh air. You know what I mean? So,
Yeah, well, in contrast, most of my code has been C, C++, bit of Java, some C Sharp, quite a lot of Python, some PHP, and it's been predominantly around system software or data engineering or embedded software, or as I say, data engineering. So very, very different stuff to the React.
Yep, for sure.
Cool. I was going to mention also requirements. One of the things about requirements is that, and this is the same sort of thing, is if we're building the requirements for something more than a trivial thing, requirements are really, really hard, and humans are very, very bad at holding all that in our heads. And I think about an example of about a decade ago, I led a team building some software for Facebook, and for one feature that we delivered for them, I think we spent 9 weeks going back and forth doing the requirements with them. In the end, I think it took us about a week to build the feature. But trying
Nice.
to nail down all the corner cases, all the scenarios, everything that they required, get a clear set of acceptance criteria, get all the edge cases
Yep.
defined in the requirements, took about 9 weeks. And the reason we could write it in a week afterwards, or maybe slightly more, it's going back well, but a very short time compared to requirements, was because getting all those requirements clear made it clear. I think
Yeah.
far too often in software engineering, we go, oh, we need this done in 10 weeks. So we'll spend a week on the requirements and then we'll start building it. And that then tends to mean that you spend a week or so building it, and then you spend a week discussing what's wrong with it, and then you spend a week redoing it, and then you talk about what's wrong with it, and you spend another
Yep.
week, and then
Yep.
we get to 12 or 13 weeks and it's still not right. It's very hard. And I think the only reason we do it is because there are such tight commercials on it to get that requirement and spend so long getting the requirements right that you can then go, okay, we finally really understand this and we totally agree with the customer. Now we can build it and get it signed off
Yep. Yep.
and delivered and paid. But it's the requirements of that feature were only 4 pages in the end.
Wow.
But it took a lot of work to get all those cases down and get everything understood and to think through all the different issues. And then as soon as you write them down and get set agreed, you then go, what about this case? And then realize that there's a whole bunch of stuff that hadn't been thought about. So requirements are hard. And that was the one feature. So when you think about a whole system, again, it's very, very hard to actually get them right. I guess that brings me to AI in software engineering. It's one of the reasons I think that AI is never going to replace software engineers. Because this whole idea that we're going to sit down and in a native language, right, English for you and I, we're going to just tell AI what to build. Well, we suck at doing that for software engineers. So how are we going to suddenly be better at it for an AI?
Yeah, it's terrible. Oh man, yeah, it's so bad. The idea that AI is going to replace software engineers is hilarious. It's like, okay, cool. Now that English language has taken over as the most common language globally, I mean, not the only, obviously, but first we'd have to be able to communicate properly in English, which is obviously not going well for the human race many thousands, millions of years later. And the idea that you can make the input the human language, it's like that's hilarious. There was Dijkstra of Dijkstra's algorithm had written about this not long before his passing around 2005, where he talked about the fact that um, you know human language input is a joke, right? He said something like, I wish upon no one the curse that their software have to be driven by human language. I mean, I'm very much butchering what he said, but the point is that the sentiment that he was trying to get across was simply like, hey, the idea that human language can become code, it's like, I wouldn't want to wish that on my worst enemy, right? That human language become code. Because what you want is machine language, because it has determinism, it has predictability, all the things that we see are lost with AI, right? You know what I mean? And you actually constrain inputs, which is like the whole substance of what we've been talking about in this chat up until now, right? You define a limited subset of inputs, a limited subset of outputs, specific behaviors that are testable, deterministic, repeatable. I've had so many times, I do use a lot of AI in my workflow because, and this makes me think about back to the cognitive difference between you and I, and where, again, like, I think it would be awesome someday if we got to work together. I'd love to learn from you because I see a lot of things that you're good at that I'm not, and maybe if we're lucky, the reverse. But, I'm definitely a bit ADHD. I don't talk about that a lot just because I don't like to walk around with that as a badge. And it's definitely a factor, in my life. But at the same time, like, I think I've got it fairly under control, if that makes sense. Like, it's not something that I see as being like, it's a spectrum, right? And so, for me, I don't talk about that all the time, but what AI does really well is it gives me a wrong answer quickly, which helps me to overcome blank page syndrome, which for me tends to have a lot of inertia. You know what I mean? Like that sense of dread of like, I have to do this thing that's really big and I don't know how to break it into small pieces and I don't know where to start. I actually am benefited by AI giving me the wrong answer over and over and over again so that I can say, oh, now I see what's vague in my own thinking about it, so that the requirements can become clearer, right? But it's just hilarious just to think about my many interactions with LLMs and to think about how many times I realized that the problem was me, not the LLM, right? It's like, oh, actually, you didn't explain this, or your language wasn't correct. I mean, there's the nuance of things that can mean many things, but then there's the part where it's like, oh, Brian, you're actually totally off in your thinking. You're in the wrong universe. And the LLM gives me what I ask for, and I realize, wait, this is the opposite of what I want. You know what I mean? So, anyway, that's just my personal experience with it.
Cool. So I think that if we did get to work together, I'm sure I will learn a lot from you. I'm sure I'll learn a lot from working with everyone. There's so much to this field that I have met junior developers who are a couple of weeks into their career, and I've learned from them, even after I've been doing this for nearly 30 years. So I think that's a big danger of software engineers. So we forget that it's so big, we can learn something from everyone, no matter who they are, where they are in their journey. Because
Yep.
even people that
Yep.
started new, they've taken a different learning path. They'll have learned different languages at uni. They'll have learned different things in their courses. Maybe they've done more React than me. They've done more JavaScript, so on. So we learn from all of it. The thing with AI that I kind of go back to is, you know, English language is hugely ambiguous, and we don't all share the same meanings of words. Even if we're going to look them up in a dictionary, we still disagree
Yep.
about what they mean.
Yep.
So I think it'll be an interesting exercise for a lot of people to try and go to your favorite LLM and try and ask it to write a function to calculate a factorial without using the word factorial and
Mm-hmm.
without using the mathematical notation. Because the example I like to go to is one of the reasons we have code and we have small languages like C and Go is because they're very precise and ambiguous and easy to parse and easy to reason about that way. Mathematics, I point to again, if you want a factorial, it's one character,
Mm-hmm.
notation. It's
Mm-hmm.
you put that clear notation, but it's very unambiguous and well understood by anybody familiar with mathematical notation.
Yep.
English, not so. And you try,
Yep.
as I say, as an exercise, go and try and explain a factorial to an LLM and get it to produce the code without using the word factorial and without
Mm-hmm.
using the mathematical notation.
Yep.
And you'll see how difficult it is to write requirements in English or whatever your first language is. And it's really, really hard. And that's just for something that's relatively simple. You think
Yeah.
about the complexity of a modern software system, and that's going to be very, very hard.
Yeah, it takes me back to 20 years ago when I started and I used to Google, how to do things. And, in the beginning, it was so painful because I had no background. Like I dropped out of college 3 times. I studied philosophy. I never got a degree. And I taught myself programming by right-clicking and clicking save as and saving the code locally, the HTML, CSS, JavaScript, and then tinkering with it. And so in the beginning, what happened for me was I struggled. I remember such incredible, painful struggles to get things working because I didn't have language to describe what was wrong. There was a precise term for what was wrong, and I did not know that term. And that was incredibly, incredibly painful. When I started, there were developers, which tended to mean maybe that people didn't go to college, and then there were people who had a computer science degree, and they were engineers, right? I don't see that as much around the kind of zeitgeist of the whole sphere right now of the industry, but it was a big thing when I started. You know what I mean? And but I'm not sure if I could have gotten a computer science degree. I'm not sure if it could have held my attention because I might have thought that some of that was rote and boring. But the hundreds and hundreds of hours that I spent banging my head against a wall looking for a term that I hopefully would have learned in, the course of getting a degree, that's a real factor, right? And they say like choose your hard, right? Like teaching yourself to program really hard, going to university, sitting through a bunch of boring nonsense that seems like it's irrelevant, very hard as well. You know what I mean? Like one time they tried to get me to teach a community college, course on software engineering, and they were teaching Cold Fusion as the core curriculum. And I was like, oh man, I wanted to help out the university, but it's like I don't want to rewrite the curriculum for $0 because they're teaching cold fusion. And don't get me wrong, like you can learn from anything, but I'm not sure if this skill is really useful to the average person graduating, you know? So anyway, I don't know. That was just my take, but yeah, anyway, all of that just bubbles up to that whole question of ambiguity around human language and that fact that like engineering, strength in engineering, for me personally anyway, looks like learning the precise term so that we can shortcut a lot of miscommunication, right? And thankfully, LLMs do have some of that, but you're always going to have some level of that non-determinism, right? Where it's actually just my thinking that is unknowingly problematic, right? There's many layers, right, where this can go wrong when you think about non-determinism, but anyway, yeah, it's all super fascinating to me, you know.
So the other aspect to that is, and this is somewhere that software engineers sometimes get wrong, the value of a software engineer should be more than just knowing a programming language. It should be having that domain knowledge and having that ability to understand the domain knowledge and translate from whoever's giving you the requirements to how do we apply that domain knowledge to the production system? How do we map it to the system? And again, the idea that we replace software engineers with LLMs and, you know, a normal person is just going to vibe code this, they haven't necessarily got the structure of how do they translate that domain knowledge. They haven't necessarily got the domain knowledge and the language to better say to the LLM, you know, what you want to achieve, even if the LLM could do everything perfectly. So I think that's again something that's missed out in this hype that will replace software engineers. I think software engineering could change, and even if we imagine LLMs could perfectly do it, I think there still has that software engineering role of translating what the business wants to actually telling an LLM to build a system. And again, I think you'd see that in that, you know, imagine the system is running a kitchen. Not that I've an experience running a kitchen, but I can imagine you still got to explain how you want, you know, as a chef, how you want your kitchen run, how you want your kitchen designed, how you want it. And you need to have the right language to say, you know, I want this implement over there. I want the sink over here. I want a deep fat fryer there. You're still going to have that terminology and that domain knowledge to be able to plan that out. With apologies to any chefs that I'm probably way off and talking about there. Going back to the LMs, you mentioned something there about you find it quite useful to be able to put it in because you don't know where to start and get the long answers out because that then gives you something to think through and challenge with. So I think the other interesting aspect of all this is that a lot of people are talking about, oh, we're not going to hire junior developers because AI can just replace a junior developer. Well, how then does that going to work? Because senior developers are going to move on, progress their career, retire, whatever, and somehow leave the industry and no longer be in. We don't have junior developers that progress. How are they going to get there? You won't know it's a long answer because you've got that experience. So we're basically saying that the only people that can drive an LLM then are experienced software engineers that can prompt it, get back something, challenge it, see that it's not right, and go through that thought process. So again, I think it can be very useful for that, but you need that level of experience. And it's replace a junior developer with a product manager or the business analyst or the founder or whoever's going to drive this. Where are they going to get that knowledge and experience from? How are they going to be able to challenge that?
It's a grim, dark, you know, dystopia, I think, with that we're looking at, and hopefully we don't go there. But yeah, I also get stuck in the loop because everybody has blind spots in their knowledge, and I have gotten stuck in the whole like, oh, this isn't working, like why? And it tells me something that I don't realize is a lie, right? So that's the biggest danger to new developers with LLMs. And because you can just get stuck in that forever, you know, you could just do that for days and not realize what's happening to you, right? And it happens to me too, you know what I mean? Like, and so I can't imagine, you know, I've done this for 20 years, what it would be like to be like, I've been coding for a couple months and this thing keeps lying to me over and over and over and over again. I mean, that just sounds dark and hopeless, you know, to be honest with you, because I know that sometimes it's hard for me to disengage. You know what I mean? It's hard for me to get out of the loop and be like, that this is not true. Like, where's the docs? you stupid machine. You know what I mean? Like prove it to me that method is part of that API. You know what I mean? It's crazy times that we live in.
That's the end of my software discussion with Brian. Join us in part 2, where we'll talk about learning Go, the value of bootcamp versus computer science degree and being self-taught, and the importance of having a community around you as you develop your career as a software engineer.